The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I will respond as soon as I can. Okay, so today, eventually we're going to get into section 10.4. But first we have some application or story problems to look at. So this is from 10.2, part 2, and we're going to start with problem number 3. And I'm going to bring that up on the screen so we can see what it says. A huge suspended LED screen is the centerpiece of The Place, a popular mall in Beijing, China. Find the length and width of a similar rectangular screen if the length is 10 meters more than 7 times its width, and the viewable area is 6,600 square meters. Okay, so we've got a rectangular screen. We know that the area is 6,600 square meters. We know that the length is 10 meters more than 7 times the width. Okay, so let's call the width x. The length would be 10 more than 7x. So what we have is this picture. The area is 6,600 square meters. The width is x. The length being 10 more than 7 times the width would be 7x plus 10. Using the formula, area equals length times width, we get 6,600 equals 7x plus 10 times x. Distributing on the right side of the equation, we get 6,600 equals 7x squared plus 10x. I'm going to subtract 6,600 from both sides of the equation. So I get 0 equals 7x squared plus 10x minus 6,600. Let's see if I can write that a little bit more legibly. 6,600. Okay, so here's our equation. We're going to use the quadratic formula to solve it. A is 7, B is 10, and C is negative 6,600. So we get x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so then we get x equals negative 10 plus or minus the square root of 100 minus 4 times positive 7 times minus, or negative 6,600 is going to be a positive. Negative times positive times negative, okay? And then we've got what? 4 times 7, which is 28, times 6,600. And I get 184,800 all over 14. So x is negative 10 plus or minus the square root of, if we take 184,800 plus 100, we get 184,900 all over 14. Now, in the original instructions, which you can't see any longer, but it didn't say anything about rounding, which tells me that 184,900 is going to come out nicely. So let's see, if we take the square root of that, we get 430. So that means x equals negative 10 plus or minus 430 divided by 14. So looking at our two different possible solutions, we've got x equals negative 10 plus 430 over 14. X equals negative 10 minus 430 over 14. Well, negative 10 plus 430 would be 420. 420 divided by 14 is 30. Negative 10 minus 430 would be negative 440. That divided by 14, let's see here. Negative 440 divided by 14 is some awful number, but you know what? It doesn't matter because X is a width, it's a distance, it can't be negative. So it doesn't matter what it is, it doesn't work for the problem. It's a solution to the equation, but not to the actual original situation. So X is 30. 7 times 30 is 210 plus 10 is 220. And we're talking meters. So the width is 30 meters. The length is 220 meters. Any questions on that before we go on to the next problem? All righty. We're going to take a look at number 4 in that same section. Let's go back and look at the WebAssign situation. Number 4, it says, a large city in the ancient world was square-shaped. Measured in miles, its area numerically exceeded its perimeter by about 124. Find its dimensions. Okay, so its area numerically, in other words, its area is going to be in square miles and its perimeter is going to be in miles. But just looking at the numbers, the area numerically exceeds the perimeter by 124. Okay, so we've got this square city. Okay, let's take a look here. So this distance here would be X, and this would be X, and this would be X, and this would be X. Okay, we're just going to call the length of a side X. Okay, measured in miles, its area, well, if it's X times, if the length is X and the width is X, the area would be X squared, right? Okay, its perimeter would be 4X. Everybody okay with where I got those numbers? All right, it says its area exceeds its perimeter by 124. So the area is greater than the perimeter. Whoops. The area is greater than the perimeter. How much greater? 124. So if we want to make this into an equation, it's going to look like that. The area exceeds the perimeter by 124. It's 124 larger. We add 124 to the perimeter. They're now equal. Are we okay with where I came up with that? All right. Now, this is a second degree equation. So I'm going to subtract 4X from both sides and subtract 124 from both sides. So I get X squared minus 4X minus 124 equals 0. So now I have a second degree equation. It's in standard form, ready to plug into the quadratic formula. A is 1, B is negative 4, C is negative 124. So X equals negative B plus or minus the square root of B squared minus 4AC all over 2A. X equals negative times negative would be positive 4 plus or minus the square root of negative 4, the quantity squared would be a positive 16. Then we've got negative 4 times 1 times negative 124, so that's going to be a plus. And let's see here, 4 times 1 times 124 is 496. All that divided by 2. So X equals 4 plus or minus the square root of let's see, 496 plus 16 is 512, all divided by 2. Now, I didn't mention this earlier, but in fact, let's go back and look at it. On problem 4, it says round to the nearest 10th. So what that tells me is that our answers aren't going to come out nicely. We're going to have to approximate. So we've got x equals 4 plus the square root of 512 over 2. X equals 4 minus the square root of 512 over 2. Okay, so the first one, parentheses 4 plus the square root of 512. Close it up, close up the whole thing, divided by 2. And I get 13.31. It said round to the nearest 10th. So this 3 would be in the 10th column. The 1 would round down. So we're going to get 13.3, and that's miles. The second one, we get negative 9.31, which would round to negative 9.3. But here again, just like the previous problem, since we're looking at a distance, it can't be negative. So let's see, it says find the dimensions. The dimensions would be 13.3 miles by 13.3 miles. Okay, there you have problem number 4. Any questions before we go on to number 5? All righty. Let's take a look at number 5. It says the matting around the picture below has a uniform width. So this width of this matting all the way around is the same distance. Okay. Let's see here. Now, it says, how wide is the matting if its area equals the area of the picture? Round to the nearest hundredth of an inch, assume x is 6 inches and y is 3 inches. So if x is 6 inches, that means from here to here. I'm drawing a picture and then I'll put the picture up there. And y is 3 inches, so from here to here. And it says round to the nearest hundredth of an inch. So again, we're probably not going to get nice numbers. It says the area of the matting equals the area of the picture. Okay. And let's see here. We'll draw this picture a little bit here. We've got a sailboat and some trees. Okay. Hang on here. So here's the picture, okay? And then we've got this mat around the edge of it. And we know that the length of just the picture is 6 inches. The length or the width or height of just the picture is 3 inches. So the area of the picture is 3 inches times 6 inches, which is 18 square inches, okay? They also tell us that the area of the mat is equal to the area of the picture. So that would also be 18 square inches. So if we took the area of the picture plus the area of the mat, the total area would be 36 square inches. So the area of everything, the picture and its mat frame, is 36 square inches. We okay with that? I'll assume that means yes. All right, now, where'd my mouse go? Here it is. Let's go back here. we're told that that mat has a uniform width, okay? So what if, let's see, let's use blue. So what if we called this width X, and we called that width, which would be the same thing, X, okay? So that mat all the way around, we're gonna call its width X units, okay? Now, consider this side right there. We've got 6 inches there, we've got X inches there, and X inches there. So that whole side would be 2x plus 6 inches. Are we okay with where I got the 2x plus 6? The X, the 6 inches, the X. All right, now, how about this width? This is 3 inches, this is X, so this would be 2x plus 3. So the whole thing, the picture and its matting frame, is 2x plus 6 long and 2x plus 3 high. Again, any question where I got any of those numbers. So using the fact that the length times the width equals the area, we have this, 2x plus 6 times 2x plus 3 equals 36. Continuing, foiling, we get 4x squared plus 6x plus 12x plus 18 equals 36. Combining like terms, we get 4x squared plus 18x plus 18 equals 36. We're going to use the quadratic formula to solve it, so we need to set it equal to 0. So we'll subtract 36 from both sides. 4x squared plus 18x minus 18 equals 0. Oh, but I see that all my coefficients are even, so I could go ahead and divide both sides by 2 to reduce it down to 2x squared plus 9x minus 9 equals 0. So there's my equation reduced down into a nice form, but I don't have a whole lot of room left on this page, so I'm going to take that equation and copy it on the next page. 2x squared plus 9x minus 9 equals 0. Okay, so A is 2, B is 9, C is negative 9. X equals negative B plus or minus the square root of B squared minus 4AC all over 2A. X equals negative 9 plus or minus the square root of 81. Minus 4 times 2 is minus 8 times minus 9 would be plus, what, 72 all over 4. X equals negative 9 plus or minus the square root of 153 all over 4. Well, 153 is not a perfect square. And again, remember it said round to the nearest hundredth of an inch. So let's see what our possibilities are. Got that one and that one. So the first one, let's see, parentheses, negative 9 plus the square root of 153, close up the radical, close up the entire numerator divided by 4, and I come up with 0.842. It's said to round to the nearest hundredth, that would be the 4, the 2 would round down, so we're going to get 0.84, and this was inches, okay? The second one, we end up getting negative 5 well, it doesn't really matter since we're looking for a length or a distance. Can't be negative. So back here, X, which is that uniform width, is 0.84 inches. So that matting is what, a little more than 3/4 of an inch thick all the way around the picture. All right. Anything else before we go on? Okay. We are now going to take a look at section 10.4. And I got an email from somebody yesterday that was concerned. It said, well, 10.4 isn't due tomorrow. Here's the deal, okay? We're going to spend today and tomorrow on section 10.4, and then the whole thing will be due on Monday. In fact, tomorrow will also include the chapter review, so then Monday we'll review for a test on Tuesday. I know that seems so suddenly, but anyway. So we're going to start on the first part of 10.4 today. And what I want to do now is close up this screen and open up a screen where I can graph. And let's see here. Here we go. All right. Have I got the screen right? Well, let's just do this. We'll start over and make sure. So can you see the screen where I've got a graph drawn out on a grid there? Somebody? Is anybody there?
Yes. Yeah, you can see.
Okay, sorry, just wanted to make sure I got the right buttons clicked. Didn't mean to wake you up there. Okay, let's take a look at the graph of a second degree equation. So we're going to take a look at the graph of y equals x squared. All right. And what I'm going to do, I'm going to make a table. Whenever I'm graphing something and I'm not really sure what's going to happen, what it's going to look like, I like to start with x values going from -3 to +3. Okay, so completing the table, if x is -3, y would equal -3 the quantity squared, which is a +9. If x is -2, y would equal -2 the quantity squared, which is a +4. If x is -1, y equals -1 the quantity squared, which is +1. If x is 0, y equals 0 squared, which is 0. If x is 1, y equals 1 squared, which is 1. If x is 2, y equals 2 squared, which is 4. And if x is 3, y equals 3 squared, which is 9. Any questions about those calculations? All right, let's see what that graph would look like. So we'll plot some points here. And we've got -3, 9, -2, 4, -1, 1, 0, 0, 1, 1, 2, 4, and 3, 9. Notice something. Notice that the graph or the y values repeat themselves. We've got what? A 1 here and a 1 there, a 4 here and a 4 there, a 9 here and a 9 there. Do you see that? Okay, I'm gonna erase those now, but over here on the graph, let's see what this picture looks like. Well, unless I messed up big time, it's not linear, is it? It's not a straight line by any means. Let's see if I can get a graph of it here. And so let's see here. So we've got this shape, and this is called a parabola, okay? I've got this handy tool here that, well, it works to some degree. I'm still working on it. Anyway, so this is called a parabola. And let's look at some of the features of a parabola, okay? This particular parabola is said to open upward. We'll also have parabolas that open downward as well. We'll look at those here in a bit. It has what's called an axis of symmetry. In this case, the y-axis. Do you see that if I folded this graph along the y-axis, I'd have the same thing on each side of the folding line, which goes back to that symmetry I noticed earlier. I showed where the 1 and the 1, the 4 and the 4, the 9 and the 9, okay? The lowest point on the graph, this thing right here, is called the vertex. When a parabola opens upward, the vertex is the lowest point on the graph. When a parabola opens downward, the vertex is the highest point on the graph. Okay, and now I'm going to get rid of that as well. So, any questions before I go on? Okay, I'm going to erase these calculations and we'll go back here. And now I want to take a look at the graph of y equals x squared, we'll say plus 2. Okay. And I'm going to put in the same x values. Now, let's consider order of operations. Okay. If x is -3, I get y equals -3 squared plus 2. What do I do next? Do I add the 2 or do I actually square the -3? Okay, fine. I'm going to square the -3, so I'm going to get 9 plus 2, which is 11, right? Okay, let's take a look at the next one. Y equals -2 squared plus 2, which is 4 plus 2, which is 6. Well, can you see that my first calculation is x squared, which produces the same numbers I have here. But then I'm going to add 2. So my final answers over here are going to be these plus 2. Okay, so this is just like that, but plus 2. Well, if we add 2, which then increases the y value by 2, what happens to the graph? Everything moves up 2 units. So we get the same shape of a graph, but it moves up 2 units. Any question about that? Okay. Again, let's erase our calculations here. Let's say that instead, I wanted to graph y equals x squared minus 3. So what would I do first? X squared. That would give me these values. Then minus 3. That would take the x squared values and subtract 3. So 9 minus 3 is 6. 4 minus 3 is 1. 1 minus 3 is -2. 0 minus 3 is -3. 1 minus 3 is -2. 4 minus 3 is 1. 9 minus 3 is 6. So all of these y values are 3 less than those y values. So what is that going to do to our graph that started as y equals x squared? Everybody's going to go down 3 units. And our graph is going to look like oops, didn't quite get that graphed. Oh, well. Now you know why I use that piece of plastic to help graph. So if we have something in the form of y equals x squared, if we add a constant, it moves up that far. If we subtract a constant, it moves down that far. You okay with that? Well, hopefully you are. Okay, now let's go to the next page. And let's see, how are we doing for time? We're doing okay. And let's go back to the graph of y equals x squared. Not sure why it did that. Let's try that again. Y equals x squared. And I'm just going to reproduce the table from the previous page. -3, 9, -2, 4, -1, 1, 0, 0, 1, 1, 2, 4, 3, 9. And our graph is here and here and here and here and here and here and here. Okay. So that's just the same picture that I started with over there. You get the general idea. Sorry about that. Okay. If I graph, well, let's see here. What if I put, or if I graph that thing, okay? Y equals -x squared. Order of operations, is that negative sign inside the square? No, it isn't. It's outside. If it was written like this, then it would be inside, but that's not the case. So we'd have y equals negative the quantity -3 squared, which would be negative the quantity 9 or -9. And we'd see that we're going to end up with -4, -1, 0, -1, -4, and -9. In other words, all of these values are going to be the opposite of those values. So what does that do for our graph? Our graph, instead of opening up, it's going to open down. Okay. Any questions there? All right. Now, let's take a look at, let's see here. Let's do this. Let's get rid of that. And here. Put this line back in here, sort of. Okay, what about y equals 2x squared? What would that look like? In other words, what if we change our coefficient to something other than just an implied 1? What does that do? Well, y equals 2 times x squared, which is 2 times 9, which is 18. So again, we get the x squared first, but then times 2. So this is 18, 8, 2, 0, 2, 8, 18. The y values are double what they were there. Well, that means this thing's going to climb steeper. Well, -3, 18, I can't put on this particular graph, but -2, 8 would be here. -1, 2 would be there. 0, 0 is still there. 1, 2 is there. And 2, 8 is there. And so what I get, and just for the sake of time, I'm going to just show that this graph actually is inside the other one. It's climbing steeper. Okay. All right. I've got one more thing to look at here. And that is, what if we've got this graph? For okay, that's here, here, and here. And I keep getting those lines off. All right. What if we go inside and we change it and we put like a -2 in there, okay, on the inside? Let's see, let's do that one in red. Okay, so let's get rid of that and go back here and say y equals x minus 2 squared, okay? And I'm going to use the same x values to start with. So now I put x inside, I subtract 2, and then I square it. So this is 25. I put x inside, I subtract 2, so -2 minus 2, and square it. So I get 16. And this is going to be what? -1 minus 2 squared, which is -3 squared, which is 9. And then y equals 0 minus 2 squared, which is -2 squared, which is 4. And y equals 1 minus 2 squared, which is -1 squared, which is 1. Y equals 2 minus 2 squared, which is 0 squared, which is 0. Y equals 3 minus 2 squared, which is 1 squared, which is 1. And I know I'm doing the calculations rapidly, but I want to get the idea of the picture. -325 is not really on this graph. -216, we're kind of pushing it. How about -1, 9? -1, 9 is right there. 0, 4 is right there. 1, 1 is right there. 2, 0 is right there. 3, 1 is right there. Tell you what, just for fun, let's go, keep going. If x is 4, y equals 4 minus 2 squared, which is 2 squared, which is 4. And 5, y equals 5 minus 2 squared, which is 3 squared, which is 9. Oh, look what our graph looks like. It's the same picture, but it's moved to the right. Come on. 2 units, which is the inverse of that. It's like when we added or subtracted a number over here, like x squared plus 3 moved it up 3, x squared minus 3 moved it down 3. But when we put the number inside, it does the inverse of what happens. So x minus 2 inside, we shift to the right 2 units. What do you think y equals x plus 3, the quantity squared, is going to look like? It's going to shift to the left 3 units. I'd have given you a chance to answer, but you haven't been answering, so I just went ahead and did it for you. Okay. So what does that get us in all of this? The form of a second degree or quadratic equation that is written like this: y equals a times the quantity x minus h squared plus k, has the following characteristics. Now, I briefly talked about the axis of symmetry. In fact, let's go back for a minute. For the black graph, the axis of symmetry would be the y-axis. But for the red graph, the axis of symmetry would be x equals 2. Okay? So it moves over 2 units. Oh, here's that 2. So how does that play into all of this? Well, the axis of symmetry is at x equals h. The vertex is at hk. Is at hk. If a is greater than 0, the parabola opens upwards, and the vertex is at the bottom, and we say it's a minimum. If the a value is less than 0, the parabola opens downward, and the vertex is a, whoops, too many humps on that camel, is a maximum, okay? So let's apply that information to some graphs, okay? Let's say we have f of x equals x minus 4 squared plus 3. So the axis of symmetry would be at x equals 4. Now, if we were graphing freehand, which is what I'm doing here, we're going to graph the axis of symmetry, and that is at x equals 4. It's an equation of a vertical line. So we don't just say it's 4, it's x equals 4. In WebAssign, they don't have you graph the axis of symmetry, but they will ask you what it is. So you'd write x equals 4 for the axis of symmetry, okay? The vertex is at 4, 3. Okay, that's the vertex. The vertex of the parabola always lies on the axis of symmetry. So whatever your x value is here, it's going to be the x coordinate of the vertex. Okay, now doing this freehand, that is not doing it on WebAssign, what I would do is I would take that vertex and I would put it in the middle of a table. And then I'd go, what, 5, 6, 7, 3, 2, 1. And I'd plug in the values, okay? And I'm just going to do this quickly in my head. If x is 1, 1 minus 4 is negative 3. Negative 3, the quantity squared is 9. 9 plus 3 is 12, okay? If x is 2, 2 minus 4 is negative 2. Negative 2, the quantity squared is 4. 4 plus 3 is 7. If x is 3, 3 minus 4 is negative 1. Negative 1, the quantity squared is 1. 1 plus 3 is 4. If x is 4, well, we've already got that one. If x is 5, 5 minus 4 is 1. 1 squared is 1 plus 3 is 4. If x is 6, 6 minus 4 is 2. 2 squared is 4 plus 3 is 7. Oh, look what's happening. This is going to be 12. So our graph is going to be what? 1, 12, 2, 7, 3, 4, 5, 4, 6, 7, 7, 12. And again, we're going to get, let's see. Oh, I plotted that point on the wrong place. That's why things were looking kind of weird. So we get this picture. Okay, so the axis of symmetry is at x equals h. The vertex is at hk. You find that point. You put it in a table and you find other points above and below it and plot them. Now, in WebAssign, here's what's different. In WebAssign, they may ask you for the axis of symmetry. They may ask you for the vertex, okay? But when you go to plot the graph, what you need to do, in fact, I'm going to do this because we have time. Let's see. Let me write this down. Y equals x minus 4 squared plus 3. Okay, we're going to go into WebAssign. So get rid of that. Give me just a minute here. I will pull this up for you. Okay, student view. I know you can't see what I'm doing here, but in a minute you will be able to. Okay. Okay. So on the WebAssign screen, let's graph this equation y equals x minus 4 quantity squared plus 3. We found out that the vertex was at 4, 3. And let's see, there was another point, was at 5, 4, I believe it was. Okay, I know it's all gone now, but so here's what I'm going to do. To graph a parabola, I'm going to click on the parabola shaped box till it's blue. I'm now going to plot 2 points. And it's important that I plot the vertex first. So my first point with the vertex was 4, 3. My second point was 5, 4. And there's the graph of the parabola. And here it has the ordered pairs. Recall, if one of your ordered pairs has weird numbers, you can come over here and you can fix it. Don't use a mixed number. Either use an exact decimal or exact whole number, or an improper fraction if you need to, or a fraction, but don't put in, like, if it's 2.5, you got to put in 5 halves. Okay. Now, you've got to put in the vertex first, because if you don't, let's plot those same 2 points, 5, 4, and then 4, 3. It thinks that this point is the vertex, and so it gives me the wrong parabola. Okay, so you've got to graph the vertex and then another point. Okay, so let's go back here and let's look at another example. Let's say you had f of x equals x plus 4 squared minus 2. So the axis of symmetry is at x equals h. Now be careful. Remember, the form is y equals a times x minus h squared plus k. So what is h in this example? Anybody? Well, it's -4, because to write this like this, it would be x minus -4. So it's the inverse of what's inside, but obvious of what's outside. So the axis of symmetry would be at -4. The vertex would be at -4, -2. So on your graph, you'd have what? A dotted line here. Your vertex would be here. You'd find another point, like you'd use -3 or -5. Okay, all right. So I'm going to stop the recording.